All right, we're back. We are MAPD714 in the fall 2017 semester, and we are week 11, part 2 of our broadcast, talking about collection views. Again, following the book a little bit. Again, next week we'll be departing from some of the stuff that the book says and going right into that persistent data chapter from the book, because I need to really hit that one hard, right? But this week we want to talk about this for a couple of reasons. There is, let me just bring up the stuff that I got for this week. So we have a PowerPoint that I'm going to be following. As normal, it's already up online, collection views. And it comes from this book, Beginning iPhone Development with Swift 4. Nice book. Some of the examples still don't work, and I had to go through it more carefully this time to make sure they all work properly with iOS 11, right? So I've replaced some of the examples from the book with my own, but only because I've tested the app to make sure it works properly in iOS 11. So we talked about UI table views, but they have limitations. And we want to make some custom cells. That's what we're doing this time around. Okay, so a couple things. Let's set up a project a little bit differently, and I want to talk about some stuff to get going beforehand. So I want to go back into Xcode. Please, I would recommend you follow me on this one because there's some stuff that we're going to talk about that's a little different. So we're going to start a new Xcode project. But we're going to do, before we get into the meat and bones of everything, I want to do, because today's a special day, like I said, it's like the second last week before we go away for our little break, right? For a week, we get a week break, and then we're back, right? So it's lesson 11. I'm going to call this lesson 11A, and because I'm going to have lesson 11B today too. All right. So this is in the fall 2017 semester. I'm going to do a couple things in this lesson, right? And this is the lesson before we get into the PowerPoint. Okay. So we're going to do almost like a pre-lesson. I'm going to talk about a couple things here to help you. Notice that there is some checkboxes that we never use right down here. So there's core data. We're going to be talking about that next week. There's also unit tests and UI tests, okay? This week, I want to start talking about unit tests, all right, which is something new, right? So for those people who don't know, anyone not know what a unit test is? It's okay to put your hand up. Everyone knows what a unit test is? All right, right? You guys did all unit tests in Node? No, you don't know? You don't know? You should have known because Node, they did it in Node, no? You guys didn't do unit tests in Node? Some people are, you kind of did it, but kind of. So unit tests are really key. So I'm going to click on unit tests. Let's include that one for this project, right? And I'm going to click on next. I'm going to definitely put it up on Git because I want to put this up on GitHub for you. Create. Now, I have a couple things that we're doing differently this time. Notice that I have two little folders, right? I have this folder here, which is your lesson 11A, and I have this other folder here, which is lesson 11A tests. Okay. What is a test? So there's a different approach to writing, software for any platform. One of the approaches is I write like normal, I write my class, right? As an example. After I write my class, I write my methods, right? As an example, and then I run my code. I debug my code, see if it works. And then if everything goes well, I might do some testing, like, quality assurance testing. That's different than unit testing. Quality assurance testing is like, okay, so I get you to test my app, right? I make it, you try and break it. I might have a bunch of stuff that I have that I want you to test. Every button should work a certain way. I have a list of things that you have to go through, a unit, almost like a quality assurance test checklist that kind of I give out to people. And then you go through everything and go through the checklist and make sure that everything functions the way it should be. All right. Now they call this unit tests as well in the real world, right? I hate using that term, in the real world, right? Like we're not living in the real world, we're living in a fantasy world, we're living in the virtual world. But people say that all the time. The real world, you get this thing. Well, it's true. You do get this other kind of work that happens. And sometimes you're a tester. One of your first jobs as a junior programmer might be some kind of testing that you do, right? And it has nothing to do with unit testing, really, right? It's testing. You're a tester. You test an app to make sure that it works. An application as well, a more complicated type of application. And you know what? I forgot to plug in, which means I'm going to die, which is really bad. So I'll plug in while I'm talking. So, but this isn't that kind of thing. This is writing software the other way around. It's almost like writing it before it's written. Okay. right? So I want you to think about a unit test as like this. Maybe I don't have a structure, but I have business requirements. Okay, so I have no structures. For example, let's suppose I want to build a card game. All right, I want to build a card game with you guys, right? I know I need some stuff in the card game. I need a structure that has, I don't know, some kind of cards, right? The card structure itself. There has to be something there so I can, when I build, you know, maybe the custom data type card has two things. It has the face of the card. If you ever, did anyone not play cards ever? Any kind of cards? Some people don't, right? I don't know. Don't laugh. It's very common. You know, not everyone plays cards, right? For whatever reason. But if think about card, like a card game where you have the face of the card and the value of the card. So you have a face and a value. Okay, that's a custom type, right? I could have a custom type, face and value. Face is a string, value is an int, let's say. All right, I could make it that way. Okay, cool. And if you think about it the traditional way, what I could be doing is I could say, okay, build a structure, right? Struct, not a class, that is a, you know, that has some kind of value and some kind of face, right? Anyone know what the difference is between a struct and a class? Some people may not. Anyone not know? Come on, put up your hand. It's okay if you don't know. You don't know. All right, that's good. So in most high-level languages, a struct is a value type. It's like a class, right? But it's not a reference type. A class is a reference type, okay? Struct is a value type. Structs, a lot of times we use them to create simple data types, like this card class. Typically in C++, if we're going to go back to a more complicated language, right? Not like Swift. But, you know, in many ways, you got to think about what a struct is. It's a different structure. That's why it's called struct, right? And it's a closure that you can use in Swift to kind of say, I want to have these variables. And in this struct, when I call the name struct, whatever the name is called, for example, card, right? I can declare a type of card, my own class type. And typically, structures do not include methods. Typically, you can include methods, but typically you don't include methods. It's just a preference. So when I use it in C++, same as a class. In C++, the difference between class and a struct is different. It's not a value type and reference type. The difference in C++ or in lower level languages is, you know, by default, a struct is public and a class is private, right? That's the difference in C++, right? Not so in Swift and not so in C#. It's not like that at all. Or even in Java, right? It is actually a value type as opposed to a reference type. We're going to talk about we're going to make a struct today. We're going to check some other kinds of structures because you may need this for your to-do app, right? Your to-do list might be a struct, right? It could be a struct that you're passing. It's a different data type that has more than one kind of value that we haven't really discussed. Something more interesting. All right, so we have this struct, and normally I say to you, okay, build a struct, go ahead. Not so in test-driven development. More or less, we do something like this. We assume that the struct doesn't exist, and we kind of think about business rules, and we test for something that doesn't exist. Seriously, that's how we start off. So there's a system that we can look at. There's a kind of a process that we go through called red-green refactor, all right, when you talk about test-driven development, right? The red phase is when you fail, and you want to fail your test first. Why? Because if it always passes and you never know that it fails, then how can you make a test, right? You have to fail it first, right? Then you make it pass, and then you refactor your code so it's better. And that's test-driven development at a very, very high level. Like I'm talking high level. There's many, many levels to this. You can also test a user interface, and we're going to get into that next semester. This semester, we're getting into more of can I test my code? How do I set up a test and all that kind of stuff? So let's start off and create our first struct. We're going to make a struct in Swift. We're going to learn about how to do that. And we're also going to talk about if I didn't have a struct, how I would do it. And I'm going to start with the test first. So test-driven means I start with the test, but I have no code. I test first. It's almost like a, you know, behavioral-driven stuff first. Before you even write one line of code, you start testing, right? Which is kind of backwards, right? Wait a minute, how can I test something that doesn't exist? Right, it'll fail the first time. right? Different way of thinking. Let's try this out. So how do we set up a test in Swift? In Swift, there's another testing. I turn testing on. You can also add tests later on. But notice over here, I have another file and another plist, preference list. There's two different projects here. I have a project here, my main project, and I have a test project here, right? By the way, this is the exact same way in Visual Studio. If you have a Visual Studio and you're running another kind of file, another project like C# or even in Android Studio, usually you have a testing project, just testing, okay? Now, if I click on this file that I created, notice that I have a couple of important things. Let's get rid of this stuff. We don't care about this right now, right? Just to make it clear. But I have this test. It looks like I have this thing, this new import called Xcode Tests, okay? Xcode Tests. What is this? Xcode Tests. That's what Xc stands for. It's pretty simple, right? Just like Xc assets, Xcode assets, right? Okay, this is the most important line in the whole thing, right here. Testable import. Testable import means, and if I make this is the name of my main full file, my main project, this demo project I'm doing, lesson 11A. If I don't have this line in here, I don't have access to this namespace, right? That means I can't access the other project at all. I must have this line in here in some way, okay? And then I have the class, the testing class. Notice that it says XC test case, right? Now, you can make as many of these cases as you like. And there's a couple things. You have something called a setup, and then there's a teardown and some additional examples, all right? Some test examples here, right? Notice what it says. It says that this is an example of a functional test case, right? So XC test assert and related functions to verify your test produce the correct results. Your setup, in your setup, what you do is you create some instance variables here. And in your setup, you can do all the setup you need for your test. Think about it as an initializer, right, for your tests, right? But you have these examples that you set up to test the, a particular function. Okay, this test example is garbage because it doesn't mean anything. And so is this right now. So let's just get rid of them. All right. Cool. Well, I want to test that I have a structure called card. And I want to be able to, assign some values to card and print it out. Right. So let's try this out. So I want to make a new test. Now, if you notice, if I just undo that, you notice that they're not overrides. These two are overrides because this is part of the regular test case. Okay. But these ones here, we can write them. So we're going to make a new function, right, which we're going to call, and usually you start it off with test. Okay, that's the default way. You must start off with test, the name test. And then you call your, whatever the thing you're testing is. So for example, we want to test card struct. Does it exist, right? Can we make a card struct at all, right? So test card struct, right, exists. Pretty simple, right? And then inside there, we want to do an assert, and it's usually an XC assert, right? What is an assert? What am I testing for? It's basically saying that when I assert something, it means that I'm making sure that some condition is true. Example, I want to test to see that, my assert, and I'm going to do this in a second. So here's the assert, different ones, true or false, as an example, or equal. I can check if something is equal, right? For example, I want some output. I want to make sure that the output is exactly like I've put in. You can test to see that this output meets the requirements. Well, we don't want to do this yet, but let's suppose I want to set up a new object. So I'm going to say var, right? And my new object is going to be called card, right? And it's of type card, right? I'm specifically doing that. Or I can also make it card, right? Okay, there's the first thing. Notice that I'm all instantly failing. So here's my failing test. Look, it's failing. And if I run it, notice if I go back up to the top, right? When I try and look at the type of test that I want to run, and how do I run tests, right? Well, notice typically what we do is when we click this button here, it actually builds the current application. We only have one current application right now, which is this lesson 11 thing, right? But that's not what we're doing here, right? That's not what we're doing in this case. We're not building an application for this one. We're just testing, right? Notice in the debug phase, I'm just going to wait for this to open up because it's going to open up my little, simulator, which is just not behaving properly. Let's just make sure that it's we size it down. And we'll bring it to the front, make sure that's in the front, and we'll also make it so it's physical size. There we go. And now I have access to the bottoms where I can rescale. But notice that's not what I want, right? This doesn't tell me anything, right? This isn't my test. Stop. But look, take a look in the debug. So I've got in my debug, right? I've got breakpoints that I can put in here. I got source control where I can push stuff around or whatever. Here's my product, but there's another one, test. And that's, Command U, right? So if I click Command U, I'm just going to turn on the sound. Please forgive me. My speakers are off right now. They're internal speakers only, right? You might hear it, but if I press Command U, right, then what's going to do is it will say build failed. Our test is failing because it says use of undeclared type card, right? So again, what I want to do with it is I want to set up, right, my test. I could do it another way. I want to test to see that this exists. That's the first thing. So now this is forcing me to create a structure to pass the test. So this is my red phase. I failed, right? Now I want to build my structure. So I'm going to go back into my other project. I'm going to right click. I know it's kind of weird to wrap your mind around, all right, because it's a different way of thinking. But I'm going to right click here eventually when it actually does something new. And I want to do a new file, right? Now notice there's different kinds of files that I can write. I want to write a Cocoa Touch class, not a Swift file, right? So let's just do this one. It's going to be called something.swift, right? But it's not going to inherit from anything. So I'm not going to inherit from any class. So it's not going to be inheriting from anything. It's not a subclass of anything else. My class is going to be called card, right? It's going to be in the language Swift, all right? Notice it says class, right? Okay, cool. And how come I can't go on? Well, because it wants to inherit from something, right? It wants to inherit from something. NS object. Let's make it an NS object for now, and then we'll kind of remove that later. Next, it's going to save it inside the regular AST. Now there's two tests. Look, it's telling me I don't want to put it in this project. I want to put it in this project. Make sure that's clear, right? And then click create. All right, so now instead of a class, we just use this as a Swift file because it's card.swift. Let's kill all this stuff here, right? And let's make it so that it is a struct. Just like we do class and then the name, we use struct, the keyword struct and the name, card. All right, so it exists, right? We can do this, right? We're good, right? And now there's one error, right? Here's my error. It says use of undeclared type card. Well, that's what we had before. What if I run this test again? Now we can declare it, right? Because take a look. We have card. We have the card itself is a struct. It's empty, right? Remember, I'm going really slow here so we can think about this for a second. And if I might, kind of do Command U, right, to run my test, well, okay, now it succeeded, but I've got this error. I got this warning, right? And the warning says variable card was never used, and that's okay. Well, notice now that I have this check mark, this green check mark. Hey guys, we passed the first test. Wait a minute. Oh, hold on a second, right? What the hell is this test anyway, right? What did it prove? That I can do a card? It's empty. It's actually an empty container that I made my card. It has no type, right, at all. So that's not really a great test. So yeah, it exists, sure. And I can check to see that it does something, but there's no assert. I don't have any kind of assertion that I can make, right? So let's add some stuff to it. Okay, well, I want to say that card.value, right? I want to make a card.value, or the card.face we'll say is equal to ace, right? and card.value is equal to 1. Okay, cool. And you know what? I want to make it so that I can say XC assert, right? And I want to basically do this. There's different kinds of assertions I want to make. I want to say that I want to check to see, whoa, I'm getting these errors. It's failing again. Sorry about my screen here. Okay, here, XCT, so this is the assertion, right? And I want to check to see that if my assertion is equal. So I want to say that, well, my expression 1 is equatable. So I want to say that, well, you know, card.face, right, is, you know, is equal to, I want to make it equal to a certain thing, right? So, you know, here's expression 1 is equal to, right, face. Okay, and I don't need the second part. Do I? And if I run it, so Command U, it says build failed. And it tells you that there's a problem, right? I got 3 errors on my build right now, right? It says, first of all, that value of card has no member face, and value of type card has no member value, and the value of type card has no member face again. So I can't test for this. Well, guess what this does? 2 members. Right? I know this is dumb. Like you look at it and you go, wait a minute. This doesn't make any sense. Why are we doing it this slow? Okay, how much chance of error do I have here? Really? If you go this slow. Now this is slower development than normal, right? Normally we write as fast as we can. We do like buckshot programming, right? We almost like a shotgun. Boom, and we just have the code there. We get it from you know, Stack Overflow, and then we just hope it works, right? It's called shotgun programming, right? This is the opposite of that. This is precision programming, right? This is where we know exactly what we're supposed to get before we even start. We know what's happening, right? Okay, good. So let's go back to our struct. Well, if you notice in our struct, we have no types. So let's do this. So the first one is some kind of face, which is of type string, right? There's a string face, right? And okay, hold on a second. And there's also other things too, right? We have our face, which is a string. Okay, can I do it this way? Don't I have to make it a var? Or even better, should it be a let? Think about it, right? Will my card ever change its value when I assign it? No. It's always going to be the same value, always, right? Therefore, it will never change, so it should be a let. And let's safer than var, right? And the other thing is the value of the card. So I've got my face and the value, and let's say the value for now is an integer. So int, okay? Okay, cool. So I've got my value and my string, and I save it. Yay, right? And maybe I want to do some kind of, you know, some kind of, you know, comments I want to put in here, and I want to kind of say something like, you know, this struct creates a simple card structure, and we'll say custom type. That's what it is, right? You know, and this is for use in our card shuffling, let's say, example. We don't have a card shuffling game yet, but we're going to make it. All right. Okay, cool. Let's go back to our test. Okay, so let's run it again. So Command U, right? And let's see what happens. It failed. What happened again? What happened? Why is this failing? It says missing argument for parameter face in call. Right? Why? I need an initializer, right? See where I'm going? It's stupid, right? If you think about it, what I'm doing, but it's not stupid. It's not stupid because it tells you what it requires. Okay, so that's different. Struct to ask me for an initializer, default, right? Do I need an initializer for a class? Right? Okay. And this is interesting. I'm using this thing here, right? How about if I just did this? Would that be enough? Could I just do this? Do I need an initializer now? If I press Command U, right? Would that be okay? Okay, uh-oh. It says face is a let constant. That was wrong. I failed. again, right? I thought that let was the right thing. We thought in our mind, let is the right thing, but actually it's wrong, right? Okay, let's go back and fix it. This is the failing test. Let's make it pass, right? So I'm going to go back to my structure. I'm going to change these lets to vars, right? Which makes sense, actually. All right, and I'll go back to this test and see if it passes now. So I'm going to say Command U, and hey, that's pretty cool. Okay, wait a minute. It's a let constant, it says. Wait a minute. It says it's a let constant. I don't understand it. I changed it. Well, how come it says select constant here? These are vars, right? I think I saved the file. Let's see. I saved it. Well, how come it did it down here? Well, I need to build, right? And if I go back down here, by the way, notice it built successfully. If I go back down here and I press Command U, right, it shouldn't give me that problem again, right? But it does. Why is that? So card.face, I'm trying to access this ace. What's the other problem? It says cannot assign. Let's go through the actual error. Face is a let constant. But wait a minute. I didn't make it a let constant. I made it. I specifically said it's supposed to be var, right? What could be wrong? Okay. Let's do this. What if I change my struct? This is how interchangeable it is, to a class, right? Struct, class, right? The card class, it says card has no initializer. It tells you right away. But look at struct. If I go struct, oops, undo. If I struct card is okay. Struct card is okay, right? I got a couple vars. But here, I got a problem. It says card face. It's equaling something, and it doesn't understand what that is. Let's just, for our particular case, if I was going to clean our build, just for a second, here's our clean succeeded, right? Just to make sure it doesn't remember something. It still tells you something's wrong, man. What's the problem? Okay. You think it's Xcode? By the way, notice how I just built this little thing by clicking there, and how it says build failed, but now it's passing these ones. And now it's failing these ones. See this? Look, right here, this little arrow. So I can test each one of these things as opposed to the whole thing, right? Well, let's just undo. We'll start going like this. We'll start saying something like this. Well, so I can't assign card ace, right, to my it says the struct card must be completely initialized before member is stored. That's a different error than I had before. Look. And that's really the error, right, that I'm getting. So ace, it's not completely initialized. Okay. Well, if I didn't do this, and if I said card is equal to card, right, like this, if I did that, is that enough, right? Well, I need to make a constructor, and now I get the same problem, right, that I had before. And if I run this test again, it says missing argument call for face in call. Right? I'm running into this looping structure. So remember always to go and look at the documentation, right? So if I was going to look at Swift struct, right? And the Swift development stuff has classes and structures, and they compare both one and the other. Here's some class, here's some struct. Notice that there's the definition, right? Here's a class and here's a struct, right? And when we talk, what we're trying to do here is we're trying to do some instancing, right? Notice that the instances are the exact same, right? And okay, cool. We got the instances that are exact same, so that's the exact same. Here's resolution for other things. We want some structures, right? We can assign different things the way it is. Here's cinema, right? Here's cinema width. Notice these are just structs. So we're not doing it wrong, right? It's dot accessor enabled. That's okay. So what's the problem? Think about this for a second. What did I say earlier? Remember we had some setup and takedown. I'm declaring a var of card, right? And I'm assigning it right away. And this one is not liking it. It's not liking the card thing because when I go back to this, right? It doesn't understand what to do. right? Do I need an import, like something like foundation? Is that what's going to save me? So I'll go import foundation. There we go. Here's my struct again. Not going to save me, by the way, but just to show you. And if I run this again, right? Fail because it's missing an argument. And if I click this, it says insert face string. That's the fix. Let's see what the fix is. It looks like this. All right, but hold on a second. It says missing argument value. It means we have to do one of these. Is there some kind of initializer like this? Did we make an initializer for our struct? Did we? No. But this is the way things work differently here, where our face is an ace and our value, which is an int, is 1. And if I save this now, even though our class, our card Swift does not have a initializer, we do our own initializing by hand here, right? Okay, so there's no constructor. We're making one on the fly. That's the difference between structs and classes, right? In Swift classes, they need an initializer. Here, it's done just like it would be if I had my own data type, right? Make sense? Yours worked? Yeah. Nah, it might not work on mine. All right, so let's see this. So now if I did this, I should be able to say card face is equal to ace. That should be my next assertion, right? So if I save this, it says cannot invoke xc assert with an argument list of type bool, right? All right, so this is what this is. This is a Boolean one, right? And I'm looking at it being equal. Well, is it looking for this card.face and then it's ace? Is that the way what it's looking for? And if I did this and press kind of tests, it says succeeded, right? Succeeded. Now look what it's telling me. It says, hey, variable card was never mutated. Consider using a let constant and replace var with let. Isn't that interesting? And if I go back to this, right? Still vars, but here inside my constant, it's now the card itself is constant. Because that's never going to change. All right, so we've got our first passing test. And this is all to make our struct work, man. Okay? All to make our struct work. Okay, that doesn't really do much. We want to make another test because, hey, guess what? We can test for one card, but I want to make a list of cards, right? And I want to call that list of cards deck, a deck of cards, and I want to initialize it somehow, right? By the way, we still haven't written any real code, right? All we've done is set up a structure for the code that we're going to write, right? Okay, so let's make this new function. Okay, another test. We're going to say func tests, right? List of type card. Okay. Okay. Well, do we have lists in? Do we have that kind of stuff? So test list, and we'll say underscore just to make sure it's the same. We'll put underscores all over the place instead of the way it is, because normally for tests we use this kind of testing structure, right? All right, and notice it becomes a test now, so I can test individually, right? And I can have its own kind of test. So I know that my test, notice I left my other one there. Why did I leave my other one there? What if I change something later and it breaks my first test? That could happen. So we leave all the tests there. So every time we run everything, we can test that, well, somehow I made a change, didn't break everything else. No breaking changes, right? Okay, so test list of type cards. So how do I do lists in Swift? Anyone know? I have arrays, kind of like lists, right? And if you look it up, if I was to go look up, if I just type in the word lists, right? And typically that's how I would think about it. I want a list, capital L, list, right? Or some kind of other structure, right? Like a map, right? Or some kind of dictionary. There we go. Like with key value pairs. That's what dictionaries are like, right? Well, I got dictionaries. That's cool. What other kind of collections do I have? Do I have a list? So let's go back to that. Hold on. You're stealing my thunder, man. Right? You're stealing my thunder. So if I go list in Swift for, right? And if I go to my collection types in Swift 4, you can see that it's going to talk about an array, there's a set, and there's a dictionary. Okay, those are the way it's called in Swift. Actually, I like the word set a lot because it makes sense, right? I have a set of objects that have a similar type, typically. Like, notice that they're values. It's a set of values, right? So I want to make a set of type card in Swift, right? That's what I want to do. And if I go down here, arrays are also fine with this. By the way, lists or sets or dictionaries are always heavier, way more costly computationally, than an array. Because really, at the end of the day, a set is an array in the back end somehow, right? We're still manipulating data somehow in the back, right? On the front end, it's a very high level structure. Just like if we were going to use a vector in C++, right? Vector would be the lowest structure we want to use. An array would be a C structure, right? And a vector is really an array with some extra semantics on the front end, right? If you think about it, right? Same thing with a set or a list. It's like an array with extra stuff, extra abilities, right? So they talked about array literals, and we want to set up this list, which is a set. And how do we do it? We have letters. We do some inserts. We can do a bunch of stuff. All right, here's a set. Here's our set. It looks like var, here's our structure, whatever it's called, is equal to a set. Uh-oh, wait a minute. How do I make it a set of cards? That's what I want. I want to make it a set of cards, right? So how do I declare a new set? So here's the empty set. Oh, that's exactly like Java, my friends. And it's exactly like C#, right? These angle brackets is like, hey, I got a generic type, right? I can put whatever type I want in those angle brackets, but I want my type. I want a set of cards, right? So going back, I want to declare this. I want to say let, right? Dec, I'll say lowercase, is equal to a new set. Notice how it says set, right? Of type card. That's what I want. Okay. Okay. Wait a minute. I got my first error. It says card type does not conform to protocol hashable. Uh-oh. What do I got to do now? All right. And it doesn't give me anything like this. Now, what is this hashable type? And if I go back to my errors, so if I read my error list and it says what it is, if I kind of double click on there and it shows me this error, right? It tells me that, hey, Tom, you had a really good idea and it would probably really work well in other languages. But Swift needs something else for me to set up a set of type card. This is my custom set, a custom card list, right? And so if I go back to my card, even though it says import foundation, first of all, do you think structs, remember structs and classes are very similar. I want to make it hashable. Like it says, can I make a struct hashable? Can I use a set of structs? So again, we search set of structs, right? Well, C++ comes up, right? How about Swift 4? Is that allowed? Right? And now you see that we have some problems, right? Because it comes up with the same, place we were before, right? Here's class and structs. We already look at this rundown here. So we talked about structs. We can do this stuff. We can set it up. We have a resolution. Here's a class. Here's a struct, right? And as we go down, structures and enumerations are value types, as we talked about before. And classes are reference types. Okay, they're reference types. So we have a struct, and it's a nice idea, Tom, but don't think it's hashable, right? Classes are reference types. We talked about that. Identity operators, equal, double equals, all these kind of stuff. There's pointers. For Objective-C, they talk about that, but they really don't talk about structs as types. Now we can go back to the other thing we looked at, which is the set stuff. Notice the set of character, right? You can create an empty set of a certain type using initializer syntax. Okay, I like that, right? So this is a set type where the set of a type element, where element is the type that the set is allowed to store. Unlike arrays, sets do not have an equivalent shorthand form. Okay, so you can't do anything like this. You can insert stuff into it, right? You can use set of strings, and that's okay. You can make it so it's like this. It'll infer what it is, but it never talks about, hey, what about if I want to make my own custom type? How could I do it, right? And the same thing goes with the dictionary. Notice dictionaries are key value pair, string with int or something like that, all right? So that's a problem. So is there a way of doing it? Can I do it? What if I change this just to check, right? If I change this temporarily to a class, this is the way to check this, and I made an initializer, right? So I made an initializer. Here's an int. And I have my parameters where, face, right, is some kind of, is face. And I have, my value, capital V, which is some kind of value. And then I do something like when I initialize, like I normally do, face and value. And maybe what I want to do here is, put in this idea of, my types. I don't want to kind of mention my types. I just want to do one of these in my initializers. Can I do that? Is that sufficient? That's my statements. And then I can put some other statements in there, like, I don't know, print face, right? And we'll print type. We'll print value. How about that? When I initialize. That's different. That's not a struct anymore. Okay, is that hashable for me though? Okay. Parameter, it says requires explicit type, right? Well, I know that my face is a string, and I know that my value is an int. There we go. Okay, we're good now. It looks like we're okay. Okay, return from initializer without initializing all stored properties. Well, yeah, because we didn't initialize them at all, right? So what it's really looking for is something like, string. So face is equal to like self.face, right? One of those kind of things, right? And then, value is equal to self.value, but it kind of doesn't work like that in Swift, does it? Cannot assign a value face to a let constant, right? So I haven't mentioned what these things are right here. Come on, guys, help me out. I want to make this work, right? What's wrong with this situation? If I name them, if I go like this, face and value, like I did before, then I have to use value, and I got to mention what those are, right? Value, face, and then I get those things. But then it says it can't be this, and if I can't put var in here. That doesn't make any sense, right? Because that's not, you don't do that up here, right? So come on, tell me what the problem is. Take a look at a typical class, right? Here's my view controller.swift, right? And if I override something else, if I kind of go something, I start typing and I go UI something or another, let's say, I don't know, content or something. And then I look at some of these initializers, look what it says. Here's my environment and then UI focus environment, right? And then I have something like a protocol, and here's a protocol. And then here's with event, one of those kind of things, right? So let's go back to that documentation when it comes to classes in Swift, right? You guys aren't helping me out. It's bad. You're gonna run into problems when you do your data type later on, right? So I've got my data, I've got my struct, right? I go to my initializers. So here's I go back down to my initialization, go back to initialization. And here's my init function. This is some initialization I want. This is the default initializer as an example, right? I could make some things private and public. Could use setters and getters. I could do all those kind of things. But really what I want to do is notice that I can initialize my struct by default here. I could do that. So I could initialize my struct if I want to. And here I have my struct with an initializer. This is the actual initializer I want to use. And notice where I have temperature in Celsius, and I just put temperature in Celsius and then whatever I get. in my struct, right? So I don't have to use the self keyword. All right. Well, it probably works the same way with classes. So if I go back here, I don't need to use the self keyword, right? And I'm saying that it's equal to face. But wait a minute, the same value. Will that work? Right? Can't do face equal to face, right? How about self.face is equal to face? How about that? And self.value, right, is equal to value, just like this we use in other languages, right? That might work, right? Because we're saying, hey, this face is equal to face, and this value is equal to value, plus we have these things in here. We don't need this in here. We can make it this underscore now. And now we have a initializer that initializes both things. It's now a class instead of a struct. Will this satisfy my requirements when it comes to being a hashable type? And if I go like this, right? Now I got other problems. Look how I broke this one, right? It says face, and I said extraneous argument labels face and value. Well, because I took them away, right? So I don't need those anymore. I can just put ace and 1 because I kind of declared that the way it is. Let's run it again. So I run this thing again. It says build failed. This one passed. This test passed, and this test failed. Car does not conform to hashable type, right? In this case, for a set, you know, about how this works, guys. You guys are the biggest library in the world here. Help me out. You guys are going to learn too, right? How do I do a set properly? It's nothing to do with a class or a struct. How do I do it? You're going to run into this problem when you do it on your own. Just letting you know, right? All right, well, okay, so it says that. It says even if I do that, it says, so it does not conform to type. So I could literally just copy this, and if I was going to go to here, and let's go up to my, you know, my biggest library in the world, the internet, and I look through it, and it says implementing Swift's hashable protocol. All right. If there's an article from 2014, right? I could do that. Here's Stack Overflow. It says da 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 da. It doesn't work, and it says you're missing the declaration hashable. Right? That's crazy, man. Like one word. Okay, let's try this out. So we're going to go back to this, and we're going to go back to making a struct again in a second, right? So we're going to say hashable. There we go. It's a hashable type. And now if I go back to my test, right, and I run this again, it says build failed. Build failed, right? I didn't build this thing, right? Hey, car does not conform to protocol equatable. All right, so why not? Because I need a couple of stubs, right? And let's just do that. It gives me a couple of stubs here. And you can see that I have left-hand side and right-hand side because it has to equate, right? Just like it shows us in our code, return left-hand side and right-hand side and of the card, so I can compare. I need a comparable. In C#, it's called iComparable. I have to conform to iComparable, right? Because if I'm using it in a collection, right, and I want to check to see if one card is greater than the other card, there has to be a way of checking. And you know what? I want to say that left-hand side value is what I'm checking, right? But is it? Yeah, because the value is really what I'm checking, not the face. The face is what it's going to say. The value is what it's really about. So let's say right now we're making ace 1, and in some games ace is 14. We have to figure that one out as well. But for now, let's just call left-hand side as an example dot card. We're going to return left-hand side dot value, right, is greater than right-hand side dot value. Notice it returns. It needs a Boolean. That's a Boolean type that's returning. Now we've conformed to it. Okay, and now it says return from initializer without initializing all stored properties. Well, that's interesting. We had var face string, right? We've got this part, and we have this hashable int. We have to initialize that too, right? Okay, hash value. That's interesting. So some value, well, we have this value. It's almost like we don't need it anymore, right? Because it's an int, right? we can just say that self.hashValue is equal to self.value for us, okay? We don't really need to do that. It's kind of weird. But for now, let's just leave it as is. And if I was to build, you can see that it doesn't break this anymore. And if I go back to here, and if I run the test again, we're good, right? You guys are looking at me going like, I have two heads, right now? Because you're like, wait a minute, how did I do that, right? Let's go back. So here's my card, but I don't want to make it a class, man. I want to make it a struct today. What's wrong with this thing? I can just change this to struct. And if I did this instead, and if I run, first of all, I build it. Does it build? Yes, this is the old way of doing things. But now if I go back to here, oh man, it says I'm failing again. How can that be? Well, no, I'm not. Right? Wait, now it says I'm passing and failing. Look, here's the problem that I have. It says, okay, type card does not conform to hashable type. Initialization of immutable value deck. Consider using let deck with. Okay, let's see if that fixes. That's interesting, right? But that's weird, right? We don't even have a deck in there. I don't want that. I want deck to be used, right? Okay, cool. I want to add different objects to my card. So this is just, hey, I want to test that the list of card works, right? And I want to add I want to initialize my card list. And by the way, normally we only test for one thing, guys. I'm just making it so that this test does a few more things. Typically, we only test for one thing, a value, some kind of thing we're doing. It's in here, right? All right, so cool. Let's do some stuff here. Let's test to see that this deck loads. Okay, so what I want to do is, when I first start off, I want to create my I want to test to see that each of my cards. There's another test I'm going to make. I can see that I want to print out my whole list deck of cards, and I should have the count of my deck of cards should be 52, right? Okay, I haven't added any cards yet here, right? I haven't added a card here. Here I've added one card, but I just made a single card, right? And I don't have any assertion in here at all. I don't have that deck is of type card, right? Deck is a set of type cards, but that's not really a great test. Let's just test to see that I can do this, right? Here's a new test. So func test, and I want to test to see that the deck or list of type card is 52 cards. So list test deck has 52 cards. I'm serious. This is how you write your tests, right? The test has to be descriptive. All right, it has to be descriptive. It has to describe what the test is about, right? Okay, so that's kind of a priority when it comes to, so I'm testing, is it of type of card? First I did my card, then I made a deck of cards, and now I'm going to test to see if the deck has 52 cards. How do I do that? I'm going to say that, first of all, can I test this here? And the answer is no, I cannot, right? So this is kind of weird, right? I could do this again. I could do this again, right? But this is what this is for, right? Where I do my setup up here. I could also set it up so that way I can set the variables so I can use them over and over again. For now, I'm not going to. I'm just going to do it each time, right? Each time I test, I'm going to have a new deck of cards. And what I want to do is I want to say deck.initialize, right? I want to do that. Okay, deck.initialize. And then I want to say deck.count. Right? I want to test that that's true. I want to say that deck.count, right? So I want to say xc assert, xct assert equal that deck. Here, I'll bring this up a little bit so you guys can see it more. Deck.count is equal to 52. Should be exactly equal to 52. So that is what I'm testing for. All right, cool. So I've got a new test, and I run it, and it fails. right? Because it says, hey, wait a minute, there's no member initialize. Well, yeah, because I haven't made a member initialize yet, right? Uh-oh, wait a minute. Deck is a set. Can I initialize a deck? How do I do that, right? Wow, I'm looking for some other kind of structure, right? I'm looking for some other kind of structure. It's almost like I want a struct or a class that is inheriting from set of type card. I can do that in C#, and I can do that in Java, but can I do that in Swift? I'm exploring structures with you today, so let's take a look at this. So what I mean is, I've got my card, right? This is nice, this works, but I want to make a new class, not a struct, a class, because now it's going to have methods. I want to have a method called shuffle, and I want to have a method called initialize, right? Okay. I could add them to my card struct, but it's only, this is representing each individual card. I want to have many cards, a set of cards, or a special set of cards. First of all, before we do anything like that, do I have some way in my deck of shuffling by default? For example, in Java, all lists in Java, you can just click shuffle. And you can't, right? I can't do dot shuffle. There is no shuffle capacity for a deck, for a list. I can do contains. I can check to see if the thing contains. I can do a count. I can do all kinds of stuff, but I can't do shuffle. Okay. This is bad. It's almost like I need another test, right? And I need another structure. So what I need, let's make another test. Before we get to this one, I want to test that, you know what, I can initialize my deck of cards. So test initialize method of deck, right? That's the initialize method of deck. Okay, cool. Well, there isn't an initialize method of deck, and if I do the same thing, let deck is equal to a set of type card, I'm going to have a problem, right? It's almost like I need another structure. It's almost like I need to say that, well, is equal to a deck, right, of cards, right? And I want to say something like so deck dot initialize is what I want to do, right? That's what I want to do. I want to be able to initialize and basically set up my deck. And the way I'm going to check that is I'm going to XC assert that my first, I want to look for ace. There's got to be ace automatically. And also notice that right now I have a couple of things. I've tested for ace as the face card and the value, but I don't have a suit. Oh man, I messed up. I forgot in my structure that I need suits like ace of spades, ace of diamonds, ace of clubs, and all that kind of stuff. How do I fix that problem, right? Guess what? These two tests have got to be run again, right? See what I'm doing? I'm changing my structure. And as I'm going, I'm using my testing to make sure that I'm 100% accurate with what I'm doing, right? Very slow. Very slow, but very accurate. All right, so let's go back. So I need another structure. So I'm going to make another one. I'm going to say another new file, right? Let's make it a Swift file this time. Next, right? And we're just going to call this file deck. Create. Okay, here it is. I'm just going to get rid of all this stuff. I'll just keep foundation because we probably might need that, right? And in my deck, let's see if we can do this. I don't know if I can. I want to make a class called deck, which is of type. What can I first of all, if I made a class deck, which I want to inherit from something, right? Like I want to inherit from string. Can I do that in Swift? Can I make a class that just a deck, special deck of strings? It says inheritance from non-protocol, non-class type string. Okay, that's a problem. Okay, but can I do this? Can I say, well, I want to make a deck of a set of cards? Can I do that? Okay. So inheritance from non-protocol, non-class type set card, right, is not what I can do. You see what I'm talking about here, right? I can compose my deck of cards, right, by using a card type, but I can't do this. By the way, this is totally doable 100% in C# and in Java. I can totally do this. If I said extends list of type card, I can totally do that in C# and Java. I've done it many times, right? But not like this. And if I look this error up, and hear me what I'm trying to do here. I'm going to make up my own list of type card, right? That's what I'm trying to do here, right? But a special list that I can extend, right? Oh, wait, but I have extensions, right? I have extensions that I can do on a set, right? Where I can add stuff to all sets, all strings. Do you guys know about that in Swift, right? That's a new thing that they brought it to Swift later on. But let's just look for this error first. All right, so here, Swift inheritance from non-protocol type, blah, 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 and it says that they're trying to do exactly what we're doing, some kind of type that they've got some generic that they're trying to make, and they're getting an error, and it says, well, you do an extension, right? Like exactly what I just said, right? So this is really what I want to do, right? Right here, I want to extend a set of type card, right? And I want to add a new function called initialize. That's what I really want to do, right? Okay, let's try it out. So in my class here, first of all, it's class deck, but do I even need this? Could I just not do one like that? Can I say extension, right? And let's try this out, a set of type card, right? Can I do that? And then in my extension, I want a new function, right, called initialize, right? And my initialize function, first of all, let's see if I can just do this. I'm going to say initializing. I can test it, right? And we'll talk about what extension methods are in a second, okay? So constraint extension must be declared on the unspecified generic type set, okay? With constraints specified by a where clause. Okay, let's take this thing, and we're almost there. Well, I almost do what I want to do, right? Okay, extend array types using where clause in Swift. Here's array of type float, and then it tells me that here's the answer: array where element is equatable, right? And then function do something. All right, well, this is what I want to do, right? But, and this is the update for Swift 3. This is Swift 2, and this is Swift 3 is equal to int. This is what it says, right? Array where element is equal to int. Well, how do I do that with sets? How do I do that with sets? So extension, methods, extension, right? Extension Swift for sets. Right? Okay. Extension for sets, sure. And how do they do it? Set func map. Okay, that's not what I'm looking for. But all sets would have it this way. All sets, not just my set. All sets are going to have an initialize method. Wait a minute. Whew, that doesn't make any sense, right? Well, I could probably do with it. It's not exactly what I'm looking for. What that means is I got to pass in the thing that I'm initializing, and it has to be of type set card, right? So I pass in an object that is of type set card and then initialize it. It listens for that. If I don't pass that type in, then it won't be able to initialize it, but it's good for all sets, right? Because what the extension method does is it allows you to extend basic types. So if I want to add some kind of funky thing on an integer, I can do that. If I want to add a funky thing on a string, I can do that too, right? So too, I can do on a set or an array, right? But I'm looking for something else, right? I'm looking for some way of doing it all at once, a special type of set, my set, right? And I want to use generics to do that. So is there a way of doing that? Okay, let's take a look one more time, and then I'll stop because I don't want to waste too much of your time. So Swift programming list protocols, generics. Okay, this is kind of what I want to do with generics, but not exactly. This is declaring different types of, like this function with a different kind of type. And I don't think it's going to nail it here, right? Because what I'm trying to do probably doesn't exist yet. Okay, cool. So function set, it's called initialize, and it takes a variable of type that I want. So let's suppose that I want this deck, right? Which is of type set card, right? Will that work? So an initialize method that only works for set card types. That's kind of the same thing. All right, so I'll save it. I'll build it. Okay, it runs. Right, did it fail? Oh, it failed, succeeded. And now inside here, right? Well, this won't work because that's not what I want. I need to pass in deck in here. And now let's see if it passes. And it's not deck. This doesn't make any sense. It's got to be this for a second that I pass in here. And I pass in deck here like this. So there is no deck. I just called it deck, right? But really, we should call it something else, right? But what this does is it says, hold on a second, missing argument labeled deck, right? Let's fix it. That's what I really want. And that's because that's how I declared it inside of my function. Maybe what I really want to call it is deck, capital D, right? Whatever the deck is called. And here, I can just change this to what it looks like this. All right, cool. Now I can run this thing and I can call initialize, but it says, hold on a second. Incorrect argument label in call, have deck expected deck, but it succeeded. Because I updated it so quickly. Right, that's why it's green. All right, so we did deck, right? But it doesn't do anything right now, right? Notice how these are my tests on the left. Take a look, guys. These are my tests on the left. 3 passed and 1 failed, right? The one that's failing is this one. Set of card has 52. And this is what this initializer is going to do. The initializer checks to see if this works. Don't worry about this one. This is just waiting because I haven't updated it yet, right? Replace deck with deck. That just doesn't work because I have to clean my product, right, and try it again, right? And now that should work. If I run the initialize that particular test, it should work. And there we go. But that's really weird. It shouldn't do that. But anyways. All right, cool. So don't worry about that. It's still passing. It shows me a passing test. Just give me this really weird argument because I changed my argument midstream. It's my fault. Okay. Okay, cool. So now let's go and do this one. So I want to make sure that my deck count is 52. So what do I want to do when I initialize is I want to add all of my stuff into my deck. But I realized I have a problem. I realized that my cards only have a face, but they also need a suit. So I got to go back. So I'm going to go back to card.swift. And I'm going to make a change to this thing where I say, well, I want my, I have a face, a value, forget the hash value for now. And I have this other thing called a suit, right? Which is also a string. And you know what? I think I want to put, the face first, then the suit, and then the value, right? So I want to put a suit next, which is of type string. And then the value, I want to change my initializer, right? I've gone and done some work, right? This is what happens in real life too. What's going to happen to my tests? They're going to fail. My other test that I did, gone. They won't work anymore because I've changed my structure. All of a sudden, my test's starting to fail. And maybe I wouldn't have thought about it, but now it's going to say, wait a minute, you got a problem because you didn't realize what you did, right? So I got to fix this part. So face, and then I want to say self.suit is equal to suit, right? This will make this, I fixed up my struct, right? No problem. And now when I go back to, I just made it so I have a suit, right? So for example, spades, diamonds, clubs, hearts, that's the suit. So I'll have an ace of clubs, a 2 of diamonds, that kind of thing, right? We're gonna make this really funky too. All right, cool. Oh man, what the heck? I got all kinds of red things now, right? Well, here I got a problem with my first test. It says pass, but now it's failing, right? It says pass, but now it's failing. It says missing argument for parameter number 3 in call, right? So I got to add that in. So ace, I want to add of spades, right? And the value is 1. No problem. I can do that. Ace of spades, value 1. I could do that. And here my, I made a mistake. Oh, come on. I want the thing to catch it, not you, right? You're too fast. Okay, this is okay. I did that okay. This is still failing because I haven't fixed it, but this was my first failed test, right? Okay, wait a minute. Man, I don't want to ever type ace or spades. I don't want to ever have that problem again. What do I need? I need an enumeration, right? An enum type. You guys know what an enum type is? Come on. No? All right. An enumeration is a funky way of, it gives me a bunch of values, right? As an example, like for example, the suits. I never want to remember quotes on a suit. I just want to know that the suit value itself has its value. For example, 0, 1, 2, 3. 0 might be spades, 1 is clubs, and 2 is so. Why do I want that? I can write spades, the name spades, right? But my value is going to be something I can loop through, right? So I can use a loop to initialize my suit, right? Okay, so that's something I can do. I can use an enum because spades is nice, right? And I have a single value. That's for the ace. But I want to be able to put in the value in here automatically. Okay? So let's make an enum or enumeration. Okay? Now notice that I have card and deck. Let's make another one called suit. Right? Oh yeah, I'm really killing you guys now. New file. We'll make another one called suit. Suit. And suit is going to be of type enum. Right? So enum suit. Okay, and we're going to have the following. I want to have so diamonds. I'm not going to do it in any particular order, right? Clubs, hearts, and spades. Okay. And notice that it says it requires it, we kind of looks at some kind of declaration, because what I want to make this, of course, is I want to make this equal to 0, right? If I do this is 0, then okay, do I have to make it var diamonds equal to 0 for a suit? No, right? That doesn't mean what it means. What do I really want to do here, right? Well, var and enums is totally different for Swift than in other languages. In other languages, that would have been purely good enough, but not so in Swift, right? So I'll say Swift for, I love this stuff, enum, right? And then we have the enumerations here. That's what they are, right? And it tells you how to do this. Instead of the word var, we use case, right? And take a look at something else. There's no comma between them all. It just has case, 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 which is actually very intuitive. I like that about it because it's not a list anymore, right? It's just one of these. Any commas. Okay. So diamonds, clubs, hearts, and spades. And notice it does the same thing here. You can also do a comma separated list like this. If I wanted to put commas, I could, right? And but I wanted to initialize to a specific value, and you can do associated values, right? Let's show you where that is. It's further down here. Yes, is equal to a 0 or whatever. You can actually put in specific values. You can start off with 1, and everything else will be with kind of raw values if I really want to. I can also make it of type, so, or of string. This is interesting. Of string, north, south, east, west. I could do that. And then it says it has an implicit raw value of south. So this south has south. This is perfect for me. That's what I want, right? But, can I loop through that? How do I loop through an enum if it has an explicit type like this, right? So I could make it so that it's a type of int. I could do that. And I could say that diamond starts off with 0, right? I could still use the commas if I want to as well. That's optional. I don't need to, right? I could do this as well. And that means clubs and hearts. Clubs will be 1 and so on. It says success identifier after comma. Yeah, I could do that, right? It means we want one of these, right? I could do that specifically, right? What this is doing is it's basically saying, well, diamonds equal to 0 and so on, and that's not working. Why is it not working? I just showed me that exact thing. Case and character, I did that. Did I make a mistake? Diamonds, clubs, hearts, case. Ah. I thought so. Put it in a line and it'll take comma, but not this way. And that means I don't need these ones. Because it's just going to implicitly find out. If it starts with 0, 0-based counting, it's going to do the rest. Okay, cool. So I've got suit, right? Well, I can't just leave it here, right? If I do this, by the way, I'm not using testing. Normally what I would do is I would make a test for the enumeration. We're running out of time. See how that works? Like we're already at 8:17 and I haven't really built anything yet, right? But you're going to need this for next semester, guys. That's why I'm showing it to you now. The whole testing methodology and all this stuff. And I'm also showing you structs, enums, classes all together in one day, just so you have some idea of how some of these things work. I want to make another one called face. So right click, I want to make another file. I want to make a Swift file, and we're going to make another one called face, right? And I want to do the same thing for my enum, right? Face. I'm also going to make that an integer, right? And what I'm going to do is I'm going to say something like this. I'm going to say that case of ace, right? That's equal to, I'm going to start counting at 1 this time around, right? So count as 1, right? I want to say case as deuce. That's 2, right? Case 3, case 4, case 5, case 6. I can have friendly names for them, right? Case 7, 8, 9, 10. Okay, now there's no 11, but there is a jack, queen, king, then ace, right? Does this make sense to you? What am I doing? I'm kind of saying, hey, before I start making all this stuff, before I initialize, I need something else to initialize, right? Because I want to initialize with a for loop, right? I don't want to sit there and go, okay, let's go each individual one, you know, ace of this and whatever. Now, there's other ways to do it, by the way. People use other ways of looping through and stuff like this. I'm going to loop through by going, you know, the outer loop is going to be the suit, and the inner loop is going to be the face. And I'm going to initialize my values that way. Okay, that's what I'm going to do. Which means that I really don't care. I really don't care if my my card has these strings in it. Do I? I don't care about the strings. These strings right now, I've used string and another suit and a value, but really my value is going to be my face, and my suit is going to be just a suit and a way of sorting, right? So that means I really don't need this at all if I don't want to, okay? I'm just complicating things for you guys just to make it interesting, but I don't need it, right? There's other ways I could set this up right now, okay? But let's go back to this example. So what am I doing is in my deck, in my sorting thing, in my initialize, I want to loop through. So here's my thing that I want to do. Okay, I'm not done yet. And by the way, it'll be error prone. I want to do a for loop, right? I want to do a for loop. So here's my for, and it says for Swift statement, right? And for item in items code, right? That's not what I want. I want a range, right? For 0 ... Remember that other thing? How do I do that? Oh man, you guys don't remember? Go back to the drawing board, right? You guys don't know how to do a for loop in Swift? My fault, because I didn't teach you, right? It's actually control flow. That's what it is, right? So for, or looping, for loop, Swift, for, right? And here it is. Here's control flow. And then control flow, they give you some examples of for loops, for name and names, if I had a bunch of names. But that's not what I want. I want a bounded for loop. That's the kind of for loop I want, right? Where I have some kind of this for index in 1 to 5, right? This is the thing I'm talking about. This is the range that we're talking about. So 1 and then ... until, right? That's what it comes. Now, just warning that this will not include this one, right? So it says 1 to 5, but not including 5, or does it include 5? Oh, it's inclusive. Oh yeah, you have to use the other one, the other value, which is like so, less than, and whatever the value is, right? So 0 ... and then less means up to but not including, right? The other one ... means up to and including, right? So for index, this is what I want in here. Instead of using the in, I'm going to use the other form altogether. So for index or count, right? And I'm going to say, and I'm going to start off, because suits start off at 1, right? So for index of, okay, we have the enum, right? So we're going to call it suit dot, right? We're going to start off at diamonds, because we said at diamonds, right? This is how instructive it can be, right? For every index suit of diamonds, right? And then ... to suit of, I believe it's hearts last, clubs, diamonds, and, or spades, haha. Right? Okay. Now here it is, ambiguous use of index, right? It says, okay, binary operator ... cannot be applied to suit operands, expected colon in for statement. Okay. So remember what I'm trying to do here. I'm trying to do this, right? Because I don't want to remember what it starts off and what it ends at. I want to do a for loop, right? But I could do what it asked me before, which is for suit. Here's something. How about if I did this? For suit in suit, right? How about if I did that? That would work, right? And then I can just basically say for every suit in suit, right? And maybe what I want to call this is suits, right? It says suit.type does not conform to protocol sequence. Okay, well, it is an integer. It has a sequence, right? So here's suit. It starts off at 0 and goes clubs, hearts, and spades, right? Let's leave this for a second. For every suit, and then I want to do for every card, right? For every face in face. For every face in face, that's what I really want to do. Do another loop. That's what I want to do, right? So for every face in face, do a loop. For every suit in suit, do a loop, right? And then what I want to do is I want to add into my set that I just got, which is this deck. I want to add, right? That's what I want to do with deck, or you know, basically push something onto this to the stack, right? That's what I want to do. I want to add or insert, right, a new member. That's what I want to do. So I want to insert the new member, which is my, you know, a brand new anonymous object called card, right? I want to push a new card, and I want to push in there the card that's going to be is I want to make it, remember that card requires me to put in a couple of elements, right? Right? That's what I want. I want a new card, capital C. And I want my card itself, which is right here. It takes a string, and an integer, right? Well, that doesn't conform to what I want to do, right? But it would be something like this. Suit, right? Face, and then value, right? Some value. I really want to just do that. Okay. I really just want to be able to do this. I want to be able to insert into the deck whatever suit I'm going through, right? So I've got my suit. That's the suit I'm going through. And then for my face, I want to go through like ace, 2, deuce, 3, 4, 5. I keep adding them in every time. That's what I want to do, right? But what about this? Suit, right? That didn't work, but face seemed to work. Well, why didn't this work? Well, here's an integer, right? That's not the reason, by the way. It's just because it fails here because it's the first failure. If I build this thing, it's going to give me, it should give me just not just this, right? Suit.type does not conform to protocol sequence, right? Suit in suit, right? Okay. Loop through enum Swift 4. Very specific because I want to be able to loop through an enum, enumerate an enum, blah, blah, blah. I got a case of washers, but it doesn't tell me how to for category and product category dot all values. Oh. Washers is equal to washers, dryers equal to dryers. And it's a static member of the enumeration. That's funny. Huh? Yeah. Because you're basically creating a list of values for this thing. These are the cases. And for everything, you're making a static member. This is an interesting way of doing it. Okay, I don't like it, but sure. All right, so let's go back to our faces, right? Sure, I like that. I'm fine with that. But what it means is that I got to declare one like this. Let. So it's a static let, right? So we'll call it faces. So let faces equal to an array of all these faces. So something like what it says here, right? Washers, dryers, and toasters. I'm just going to make an array of ace, deuce, 3, 4, 5, 6, 7, 8, 9, and I don't like this. Jack, queen, king, right? Here's this, right? But it's got to be static. Just like instead of just a let, it's going to be static. Static, what's static? Static means I don't have to initialize or instantiate an object. It's part of all members, right? It's kind of a really weird hack, I think, in this case, to do it this way, but that's fine. I'm okay with it. I'll do it. Okay, let's do this. We've done that. And let me just do the same thing for my suit. That's going to be a little bit shorter. Let's get rid of all this stuff right here for now. So my suit is going to be static let suits. Notice I'm making it lowercase, is equal to an array, which is going to be diamonds, clubs, hearts, and spades. Right? It's going to be essentially the same thing. Right? But in my deck, I'm not going to go suit. I'm going to go suit.suits. Right? And face.faces, which is kind of weird. But okay. No problem. All right, we got a problem. We did that part. That's initializing, right? And this little code we got going on. But that problem that I have is I want to insert something. And you know what? Now I figured out that I don't need to do all that stuff with my struct. I can simplify my struct even more, right? So if I go back to my struct, this is the refactoring phase, guys. So if I go back to my struct, which is a type card, right? There's my card struct. All right, so I was listening for value, and I've got my face and my suit. Well, now I'm gonna make them all integers. So I'm gonna say my face is an int, and my suit is an int, as an example, right? Int, int, int. My value I don't need anymore, right? Because my face is my value. And now I'm gonna say my left hand face and my right hand face, right? I'm gonna check my face card, whatever it is, right? 1, 2, 3, or whatever. And this changes this altogether, which means my face, and should it be face and suit or suit and face? I think I like suit and face more. Oh yeah, I'm really messing things up, right? Suit, which is of an integer, and face, which is also of integer. I don't need this. Value is gonna be of face, and this is gone. Oh yeah, man, this is really messed up now. And I want to move these around because that's how they should be. Make them like this. Oops. Move this like this. We're going to take a break in a second. Just after I prove my point of this insanity, right? Okay, cool. That's my new card. So face and suit, and I don't care about the value is the suit, right? Or is the face. The face is the value, right? So 1, 2, 3. I'm going to start counting at 1. The suit starts at 0, 1, 2, 3. It's just a placeholder so I can see what it's going to say, right? So I can loop through. And now I should be able to do this, right? Suit and face. Now it says cannot use mutating member on immutable value, right? I want to create a new card, and I just could do that by doing one of these. I can say var card is equal to this. That's what it's really asking for. It doesn't want me to do this here. It wants me to do that here, like this, and then pass in card, right? And suit and face. Why? It says cannot convert value of type suit to expected arguments. What does it say here? Oh, of type int. Raw value. Sure. No problem. Raw value. Yes. But it's an enumeration. I forgot. There we go. And cannot use mutating member on immutable value. Dec as a dec is a let constant, right? Here's let constant. I said dec insert. There's my dec, right? It's a let constant, and I want to insert something into the list, and that's causing me a problem now, right? I'm passing in a reference. My dec is of type set card. That's the reference that I'm making, but it's not accepting that as a reference. It's saying that it's an immutable type, right? Because it thinks that this particular thing right here, there's no reference to my dec. It thinks I'm passing it by value, right? Does that make sense? And whenever I pass anything into a function, by default, right, that function it's a constant value. That's how we do it here. So this is all fine and dandy. This is beautiful, but this doesn't work now. How do I fix this? Right? All right. Pass set by reference Swift 4. Swift pass array by reference. It's not an array, it's a set. How to pass Swift array by reference? Sure. I guess that's the way it's looking like. Class, da 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 da. And it doesn't do it. How about up here? Does it have a solution? Structs in Swift are passed by value, but you use the input modifier to modify your array. Classes are passed by reference. Array and dictionary in Swift are implemented as structs. That's the problem. Array and dictionary. What about sets in Swift? Let, its default operator can only be let. Omit let. Function input. Oh, okay. So can I do that if I put input in there? And would that work? Doesn't like that. Was that square brackets? Who said that? No. Deck is a input loc. Oh, the square brackets is here, right? Because it's of type. That's the array, right? But I'm not sure if it works with sets. Getters and setters. Pass set by reference. I said, like I said, it's with 4. I'll take a short break after this. And I don't think there's a solution for that, my friends. There's a solution for an array, but not a set. Let's take a short break. When we come back, I will have a solution for you that's reasonable. Okay? So I think we all need a break.